Hi, Katie. How are you doing?
Good. How are you this morning?
Good.
Um, so I'm still trying to wrap my head around problem 20 for combinatorics, that big one.
Right. Yeah.
um, so just to make sure I'm understanding the question. So we've got like a stack of cards, right? Like from 1 down to n. And so we're taking off, we pick a number and we take off say 2. So we pick off 1 and 2. And then we
Mhm.
can't take 1 or 2 again. So now we have to do anything from 3 up to n, right?
Okay. Yeah. Yeah.
Okay. Um, and so then we're just going to keep going until we get to the bottom of the pile.
That's right. Yeah. Until the pile is totally exhausted. Yes.
Okay.
So
Um,
the reality is the minute. And the way they set up I don't have my book in front of me right now, but the way they set up the problem, didn't they say like whatever number you choose that you go down to the card with that number? Is that how?
yeah, I think so. Um,
So for
remove,
instance,
yeah.
if I were to pick 7 first, and it doesn't really matter if the cards are in on top and 1 on bottom or 1 on,
Okay.
I don't think that changes the computation.
Okay.
So if I pick 7, then I'm going to go down to 7 and remove those 7 so that 8's on top now, right?
Right.
And then if I were to pick like 6 next, I would just pitch it, right? I mean, that's I wouldn't count down 6 more cards
Right. Because you've already taken
on,
out card
right?
number 6.
So the only thing that would affect me is if I happen to choose a number that's bigger than 8 or 8 or bigger. Does
Okay.
that make sense?
Yeah.
And what you're trying to do is um, figure out what's the probability. So suppose I was in a situation where I picked 7 first.
Hmm.
You're trying to figure out what is the probability that, I'm going to pick 8 next or something.
Hmm.
And when 8 is actually on top of the deck.
Okay.
Okay. So does that make sense?
Yeah. So basically, you're asking what's the probability that at some point you're only removing one card off the pile?
That is exactly right. Yes.
Okay.
Yes. And I have a solution written up, and I'll definitely send out some more hints. If I just, man, I think that this is a good one to kind of have to think through.
Yeah, no, last night I was kind of trying to think because I saw the video of office hours where Elise and Ellie were talking with you about that.
Yeah, yeah,
So trying to kind of think through wait, why is that the universe?
yeah, yeah. So the issue is a lot of choices kind of end up being irrelevant, you know, uh,
Mhm.
depending on what you have chosen so far. Other stuff ends up like not mattering. Uh, so I mean, my suggestion to you is to kind of break it down into like, well, how many you can think of a drawing sequence as like a permutation, okay?
Okay.
Because I mean, like a drawing sequence is basically going to be a permutation, but there are certain permutations that will you know result in you drawing. Okay, so let me just kind of, here's a big hint. So if you let's see. So if I draw like the number I, okay?
Hmm.
If I draw the number I, then that means I'm going to remove all the cards down to I.
Hmm.
Suppose I wasn't on top when that happened. Then what would have to happen next? What would have to happen next between me drawing I and the moment in the next moment that I do something, if the next thing I'm going to do to the pile itself is actually pick the card I plus 1? What would have to happen? So I drew I. Yeah. In
Hmm.
fact, here, okay. So let me do this. Uh, I'm like obsessed with my iPad right now. So here we go. Oops, there's a bunch of junk in here that's all right. Okay, so if I went, can you see that? You see that all right, Katie?
Yeah.
Okay. So if I went, okay, so if I drew I,
Mm-hmm.
okay, so I've done a bunch of stuff. At some point I draw I,
Mm-hmm.
okay? Well,
Yeah.
what would have to happen between I and I plus one, where at this moment, I plus one is on top? What would have to happen for that to actually occur? What could you tell me about the things that are between these two? What would have to be going on with the things between those two?
Well, I mean, nothing in there, right? Or am I just thinking of this wrong?
Well, because I mean, what I'm saying is you're drawing a bunch of random numbers, yes?
Mm-hmm.
The minute you draw a random, so that's why I think of this as a permutation, right? So I think of these drawing sequences as permutations of one, it's permutations.
Okay.
So what would have to happen? So think about it. What would have to happen there, and what would have to happen here? Okay. So that is, I want I plus one to be on top and drawn
Okay.
at that moment right there. So what would have to be going on with those other choices of cards, to make that happen?
Well, so you're gonna have to draw I and then draw I plus, like choose I and then choose I plus one, right?
Yeah, but I could have drawn other numbers between the moment I drew I and the moment I drew I plus one, right?
So is I and I plus one not consecutive cards?
They are consecutive cards. But what I'm saying is, okay, so let me so here let me think of an example here. So suppose that like I was equal to 5 and I plus 1 is 6. Okay.
Okay.
Then maybe the drawing sequences the drawing sequence looked like this. 2,
Mm-hmm.
I drew 2 first. Okay, and then I drew 4, or maybe okay, but then I drew 4, and then I drew 5, and then I drew 1, and then I drew 6. See, so there's I, and there's I plus 1 right there. Yes. And would I plus 1 be drawn at the moment? And by the way, there's stuff to finish this off, but while we're concentrating on is 5 and 6. So think about the pile itself. Let's think about 1 being on top, just to make this, simple, so that the numbers match the actual cards being drawn.
Okay.
The first thing that you would do is you would take off cards 1 and 2. Yeah.
Right. Mm-hmm.
And then what?
Then you're gonna take off cards 3 and 4.
We're gonna take off cards 3 and 4. That's right.
Mm-hmm.
And then what?
Then you take off card 5.
Then you take off card 5, and then what?
Well, I guess I'm confused on where that one's coming from, because I guess I thought once we had hit a certain number, we couldn't go back.
Well, so we're just drawing numbers from, there's just a set of numbers, 1, 2, 3, ... n, right? And all I'm doing is I'm just drawing these numbers out. So like the first thing I did was I drew a 2, yeah?
Oh, so you didn't draw off 1
And
and
then
2 when you drew out the
thing I
2.
did is I drew a 4. And once you draw them, they're not in there anymore. And then I drew a 5. Does that make sense?
Okay.
And then I drew a 1. And then I drew a 6. Pretty
So
sure
when you,
that's how they're setting up the problem.
okay, so I guess I was thinking,
That's why it's a permutation, right?
oh, okay. I was thinking like when you drew off the 2, you also had to bring everything on top of it with it. So that means to draw off, like to go back to your original question, to draw off, like have I plus 1 on top and have it be drawn, you'd have to draw everything before I plus 1 already.
Well, not necessarily, because look at this example we just did right here. Did I draw 3?
No. Okay, never mind.
and 3 is gone. Yeah. Okay. So, and yet 6 would be on top, right? This thing would be on top and drawn. Does that make sense?
No, I'm sorry. Why is 6 on top?
Because the cards were like, the cards were like 1, 2, 3, 4,
Mm-hmm.
5, 6, 7, etc. Right?
Okay.
And so when I draw 2, what happens? Those are gone. Yeah.
Okay.
And then I drew 4, and what happened?
The 3 went away too? Like the 4
The
and the
the
3?
3 and the 4 went away.
Okay.
Okay. And then I drew 5, and what happened?
That went away. The 5 went away.
And then I drew 1, and I say, well, I already took 1 off. And
Okay.
then lo and behold, boom, we hit
Okay.
at exactly the moment that it's on top.
Okay.
Does that make sense?
Yeah.
Yeah.
Okay.
So for I plus 1 to be on top and drawn, so let's think about this together.
Mm-hmm.
What would have to be true about all the junk before I and between I and I plus 1?
Ooh.
So does the setup make sense now?
Yeah, the setup makes sense. Just I'm just still trying to think through, you
Yeah.
know,
Yeah.
how to kind of generalize this basically. Um,
So
um,
so 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 okay. So like duh, 5,
mhm,
6, duh, right?
right.
So what would have to happen with the stuff before 5? What would have to be true about all these numbers?
They'd have to be less than 6.
They would have to be less than 6. In fact, they would all have to be less than 5, right?
Right.
Okay. And it's important that this 5 was drawn. Why? Why was it important that 5 was drawn at some point?
Oh, because we had to make sure that the 6 would be on top.
Yeah, this makes
Okay.
sure that the 6 is uncovered.
That makes.
That is on top. Make sense?
Mm-hmm.
And now what about this?
So then that's just gonna have to be stuff that's less than 6.
Right. Really less than 5 still, yeah.
Right. Yeah.
Yeah.
Okay.
That's exactly right. Because if there were any number in there, and then this stuff over here, it's like, who cares?
Right.
Yeah.
Yeah.
Right? Who cares? Uh, so yeah. Now here's the thing that's kind of interesting, Katie.
Mm-hmm.
Um, these things are permutations. But there are some permutations that are gonna, I mean, I guess this probably isn't very surprising. Sorry. It's not super exciting. Uh, the, I thought I was gonna say something exciting, but I changed my mind now. Um, so like there are certain permutations because because actually okay, so like in the oh yeah. Okay. There are certain permutations that will actually accomplish like 5 being on top and being drawn at the moment,
Right.
6 being on top and being drawn at the moment. But I think they say to stop the minute that happened.
Um, I don't think so. It just says what's the approximate probability that at some stage the number chosen is the card at the top of the pile.
Well, okay, but what was the algorithm they described? Describe the algorithm to me.
Yeah. Successfully pick a different random number between 1 and n and remove all cards in the pile down to and including the card with this number until the pile is empty. If the chosen card number has already been removed, pick another number.
Yeah. So do you see how this is a permutation? Do you see the connection to permutations?
Yeah.
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 Um, so, okay, so we just keep going till the pile's gone.
Hmm.
Okay. Well, that's interesting. So that means the moment, yeah, that's okay. Yes. Okay, so that's why the moment that you choose in, guess what? You're done.
Yeah.
The minute that you choose in, you're done.
Right.
And then stuff literally doesn't matter at all after that.
Right.
So if n was like, 10 or something,
Hmm.
and if you had a permutation of choices, the minute that you see 10 in there, you know that you've evaporated the pile.
Right.
And you would just kind of stop, and the stuff after that doesn't matter.
Okay.
But this right here, what I'm talking about, is really the key. So it's probably not surprising to you that permutations can give rise to, multiple cards being on top and being drawn at the moment they're on top, right? Because, for instance, if I happen to see a 4 over here,
Hmm.
if I happen to see a 4 over here and everything else was less than 5,
Hmm.
that was true of this thing on the previous slide, right?
Right.
Like I saw a 4 over there, there was 4 right there.
Yeah.
Everything else was less than 5. Well, it happened to uncover 5, and 5 was also on top and drawn. Right?
Right.
So you can see how these things can start to overlap with one another, and why it would be necessary to use inclusion exclusion to pull this off.
Yeah.
Does that make sense?
Hmm.
So yeah, that my big hint to you is kind of think about this. Hopefully that's a little bit helpful, at least giving
Yeah.
you a point of where to go.
Hmm. So we're gonna be talking about then basically like as far as like when we're defining sets for inclusion exclusion, or defining the universe, it's just gonna be a bunch of sets of sequences, right? Or of permutations.
Yeah, it's going to be a bunch of sets of drawing sequences. That's right. Yeah.
Okay.
So like AI or like A1 will be the number of drawing sequences. And by the way, they're kind of like they're sets of almost like incomplete permutations.
Right.
You stop this nonsense the middle, or you stop this nonsense the minute that you draw in. Yeah.
Hmm. Yeah.
So you have a whole bunch, the drawing sequences aren't exactly permutations. They're sort of like incomplete permutations.
Okay.
Because the minute that you draw in, you're done. The pile is gone. Yeah.
Okay.
And so the way I defined it, I mean, if you go back and watch that little discussion that I had with Elise, and I don't remember who else was it. Was that Ellie and
I
Elise?
think so.
Then like I defined A1 to be like the number of drawing sequences where 1 was on top and drawn at some
Okay.
point. But that's sort of stupid, you understand?
Right.
because that's like, that means, okay, what does that mean the incomplete permutation started with?
1.
Yeah, that's it. Yeah. Okay.
Okay.
And right, and then you have, A2 being like the number of the number of drawing sequences where 2 was on top at some point,
Hmm.
and was drawn, okay,
Okay.
etc.
Hmm.
And I used inclusion exclusion on the actual probabilities themselves.
Okay.
Um, but that's going to require for you to count all of these drawing sequences.
Right. Yeah.
And then you just have to count all those drawing sequences that happen to select 1 at the right moment, select 2 at the right moment,
Okay.
etc. Yeah.
Okay.
And that's why, like this one right here, you kind of are the reason I wanted to think through that is this is a simultaneous situation. Like if 4 happened to be in here somewhere, this is a simultaneous situation where both 5 was on top and drawn,
Hmm.
6 was on top and drawn.
Right.
Yeah. And I think if you think through that a little bit, you'll start to see, oh, I see what's happening.
Okay.
The problem is you're not going to be able to count things. I think at some point you have to, like, because the formula is so crazy,
Yeah.
you end up like I had to like approximate with, like, I think I put that in there in that other video.
Yeah, you said the power series of E, I think.
Yeah, I had to approximate with
Right.
that. And then everything got really, really simple all of a sudden.
Okay.
Yeah. It's a helpful problem to have to think through.
Hmm.
Yeah.
Okay. Cool.
How's everything else going?
Pretty good. Yeah, a few more problems. I just think I know generally where I'm going. Just need to go in and define sets a little better. So,
Okay. Yeah.
yeah.
Is all the other classes going well?
Yeah. Yeah.
Okay.
Transition to online seems to have gone pretty well. So that's been really good.
That's good.
Yeah.
Yeah. Glad to hear it. Yeah, I have this little iPad thing was kind of a revolution in my thinking. At least I'm able to kind of write things without having to like unplug my machine and go up to a whiteboard or something. So
Hmm.
that's nice. I mean, it's not quite as nice as my handwriting on the board, I don't think, but yeah, it works all right.
Yeah.
Okay.
Yeah.
Yeah. Anything else?
I think that's it for now. Thank you so much.
Oh yeah. Yeah, no problem. All right.
Bye.
Bye. See ya.